I hope the screen is visible to you. It's unit number
Yes,
5.
sir.
Yeah, it's unit number 5, not 4. Unit number 5. Okay. So we'll see the content of the unit number 5. It is basically on state variable analysis of the system. What is the state variable analysis of the system? So we'll see the concept of the state variables, and state space. Then state space representation of LTI system using physical, phase, and canonical variables. Diagonalization, relationship between state variable model and the transfer function. State transition matrix and its computation. Solution of state equations, controllability, and observability. Coming to the background of this state variable analysis, in all previous lectures, we used time domain and frequency domain method to study behavior of LTI, that is linear time invariant system, or the control system, and that is called the conventional approach. Basically, in this approach, that is nothing but state variable, we model the given system in the form of transfer function. There are basically two methods of system analysis. One is a classical. Under classical method or conventional method, you have used root locus, transfer function, Bode plot, polar plot, Nyquist plot, and these are applicable mainly to the linear and time invariant system. But the state variable method is the method where we can apply this to MIMO, that is multiple input, multiple output. That doesn't mean we cannot apply classical method to MIMO, but it becomes complex and tricky. So this is best. Classical methods are best for single input, single output. For multiple input, multiple output, state variable method is best. Again, we generally use linear and time invariant system to apply classical method. Whenever it is non-linear system and time invariant, then we move for the state variable method. Let's have some background of this. LTI system, that is linearly time invariant system. You can see here x of s is equal to y of s. You can write y of s is equal to 1 by s into x of s. So your equation transfer function, that is output y of s upon x of s, it becomes 1 by s, is nothing but the integration. Then another, if your x of s is the derivative, y of s is the derivative of x of s, then your y of s can be written as s into s of x, nothing but y of x upon x of s, that is transfer function in s domain will be equal to s, is nothing but of course derivative agar liya to we'll get this. So this is all about what linearly time invariant system. But what if I have time variant system like this? Then the system may be y of s is equal to x of minus s, and then if you want to find out y of s upon x of s, it is not possible. Again, related to non-linearity system, if your y of s is x of s plus x of s, your y of t is say x square of t, then you cannot define y of f upon x of s. So this is kind of non-linear system and a time variant system. So for these two systems, we will be looking into the such kind of system, and we'll be using state variable method, wherein in earlier methods we have not yet considered the initial condition of the system. Like we have RLC circuit and we use that for, in the past there might be certain charge on capacitor and the inductor, as they are the energy storing device. Therefore, whenever we apply another input in the present, we have to consider what was the initial condition of capacitor and inductor, and that can be done in state space variable here. Am I audible?
Yes, sir.
Okay. So moving to the next, limitation of classical or transfer function based method. It is applicable only for LTI system, only applicable or suitable for single input, single output, becomes complicated for MIMO. That doesn't mean multiple input, multiple output ke liye we cannot use. We had certain examples there for 2 input and 2 output, but it becomes complicated as the number of input and output increases. Do not describe the initial state or initial value of the system, of course, that we discussed. Only gives zero state response. That means which depends on only on present input. That is called a zero state response. Advantage of state variable or space method. Consider all the effect of initial condition. This is one of the advantage. Can be applied for non-linear and time variant system. Second advantage. Can be applied for multiple input, multiple output system. And any type of input can be considered for designing system. In previous method, we had some specific type of input like unit step, likewise. Here, any type of input can be considered for designing the system. Now, the concept of state space model. Initial condition describe the states or states of the system at t is equal to 0. The states can be regarded as compact and consigned representation of the past history of the system. As I said, what was the initial charge on capacitor is nothing but past history. The state of the system at any time t is actually the combined effect of the value of all different elements of the system which are associated with the initial condition of the system. So the state can be defined as vector called state vector. Now you can see this simple diagram here. There is multiple input, multiple output system where I have x1, x2 up to xn input. This is called input vector. Then we have y1 to yn output vectors, and some states are there which are represented by x1, x2, x3. Likewise, some states are there. So this is the state space model, simple. Now its representation is in matrix, like it is x dot, it should be x dot n by 1 is equal to A matrix of n by n, x matrix of n by 1 plus b plus u. I'll read it out. Then y is equal to c into x plus d into u. So we'll see what is that. That is x dot is nothing but the differential state variables. What are the different number of state? If I have RLC circuit, that is 1R, 1L and 1C, then there are two energy storing element, that is L and C. So there will be two states into the system. We'll see later on. N is the number of state variable or effective storing element, as I said now, or initial values or time constant, or it may be order of the transfer function, where u is the input vector, where m is the number of input variables, where y in above equation is the output vector, where p is the number of output variables. A, which is n by n is the system matrix, b is the input matrix, c is the output matrix, and d is nothing but the data transmission matrix. Here these two equations can be represented in the state space model like this. Equation 1 can be written like x dot, that is derivative of course, x dot t is equal to a into xt plus b into u of t. You know u of t is nothing but input. And equation 2 can be written like y of t is equal to c of xt plus d, that is what, system matrix into u of t, that is input. So if you draw the state space model for this, it is very easy. What you have two states here. One is x dot, another input is what, x of t. So you can have, we have initially seen that x dot t, और उसका हम x dot t is nothing but what, dx of t by dt. And if we take integration, 1 by s is nothing but integration. If we take integration of that, you may show integration sign here. If we take integration of that, it will be x of t. So simply whatever the equations are there, same is modeled here. You can see here u. Let's see what is y. Okay, what is y and what is x dot t. First of all, we'll see what is x dot t. X dot t is nothing but what, a into x of t. Here is x of t into a. So here the signal will be a into x of t plus b into u of t. So this is u of t and this is b. Combined together, it is x of t. Then what is y of t? Y of t is nothing but c into x of t. So here is x of t and into C matrix is there, output matrix. So C will provide you this term C into x of t and plus D into U of t. So where is U of t? Here is U of t, in which we use this D. D is a system matrix, of course. So this will be D into U of t. Combined together, plus sign, you will get Y. Okay. So this is what state space model, whatever we have seen, this one. We'll see the numericals, then it will be more clear. Okay, so the first numerical is obtain the state space model of the given electrical network in standard form, given that t is equal to t0, I of t is equal to I of t0, V of t is nothing but V of t0. That is nothing but current and voltages. Then you just see the network. There is R, L and C, out of which only L and C are the energy storing element. R does not store any energy, so it will not retain any past value or initial value. So there are two energy storing element, that is L and C. So minimum two states variable are required. Let's see what we'll see. U is what, input हमने देखा है. We are converting it into the standard form of state space model. U is nothing but input, so we wrote U is equal to Vi of t. Y is nothing but output, so we wrote V0 of t equal to Y. Then two states are required. X1 of t, this is what, this is one of the state, and one of the state is current will change and voltage will change, so it is equivalent to the current. Another state is say x2 of t is nothing but say voltage. So system say जो भी whatever is the network form network, you will find out these parameter, that how many number of states are there and what are the input and output. Then we'll apply KVL to the inner loop. Of course, the KVL is very easy. VI will be equal to VR plus BL plus VC. So this is the equation for the given network. Let's rewrite this. Vi of t will be equal to, VR कैसे लिखोगे? It will be I of t into R plus inductor का voltage, it will be L di of t by dt, and capacitor voltage is plus 1 by C integral of I of t. Then what is this capacitor voltage? Your capacitor voltage is nothing but the output. So we may write this 1 by C I of dt is nothing but capacitor voltage, is nothing but your state, is nothing but your one of the state, that is x2. So x2 is the state. So just rewrite this equation in the form of standard state space model. V of t is replaced by u, I of t is replaced by x1 of t, because I of t is nothing but one of the variable first state. Then r as it is, L di of t क्या रहेगा, d by di of t is nothing but d x1 of t by dt. So I will write x dot 1 t, that is nothing but derivative of this x1 of t, plus what is this 1 by c integral of I t dt is nothing but x2, we already mentioned here earlier. So this is x2. So from equation 1 we obtain this. I'll highlight this. From equation 1 we obtain this. It is in the form of now elements of the system, input, and the state of the system. Let's go for expanding this. I want this equation in the form of state. So I will, what is state here? That is x dot 1t. I took it on left hand side and remaining part on the right hand side. It comes यहाँ पे small typing error. It's okay, no worry. Okay, so here I have x dot 1 t is equal to u by L minus coefficient of x1 of t is r by L minus coefficient of x2 of t is 1 by L. So finally we will write this in terms of what, sequence of the state, that is x1, x2, x3, xn, and then the input. So x dot of t will be equal to minus r by L x1 minus 1 by L x2 plus u by L. So this is equation number 2. Now what is Vc? Vc, that is capacitor voltage, is nothing but output voltage. V0 is nothing but state 2 x2 is nothing but 1 by c integral of I of t. We'll differentiate this equation on both sides, because what I am interested in, now I have x dot 1. Now I am interested in x dot 2, that is derivative of x2. So we'll differentiate, we want state x2 as well as derivative of that. So we'll differentiating both sides. You'll get x2 dot will be equal to 1 by c x1. So this is equation number 3. And what about the output? Output we took, it is equal to y. So I need output function. So y of t will be equal to v of t. And v of t is nothing but Vc, capacitor voltage. And capacitor voltage is nothing but your state x2. So we got this all 4 equation combining. And from these equation, we got this term, that is x dot 1 and x dot 2. We wrote it in matrix form, then kept all the values. You may easily write this. These are the states. This is what, this is the system matrix. Then these are the states x1 and x2. These are the input vector, and y will be what? Y is here somewhere. Y is nothing but x2. So you can see y of t is equal to output vector and states. So you can see y is nothing but only state is x2. Thereby this term is 0 and this element is 1. So y will be equal to x2 here. So here we wrote this standard matrix for state space. then we may draw the state space model. And once you draw the state space model, you can the numerical is over. Now, first of all, look at this block. What we need? We need four things. Two states, that is x1 and x2. I will not say t every time. And x1 dot and x2 dot. So you just focus on it. How we'll get x1 if we integrate x1 dot. So you can directly write x1 in block integration and x1. Similarly, what you want, x2 or x2 को if you integrate, you will get, sorry, x2 dot को integrate करोगे, you will get x2. You may write 1 by s here, okay? अगर integration sign नहीं लगाते हो तो 1 by s block is nothing but integration, and only s block is nothing but derivation that we have seen on second slide of this lecture. Okay, so what we got, x1 dot of t, x1 of t, x2 dot of t, and x2 of t. Forget about another element. I will put one by one. So मैंने इतना ब्लॉक निकाल लिया है यहाँ से यहाँ तक, बाकी निकाला नहीं है, ऐसे समझो. ये दो ब्लॉक मैंने निकाल लिए हैं. Then go for what is x1? What is x1 of t? It is summation of something. Okay, so summation of what? It is x1 of t into minus r by l and x2 of t into minus 1 by l. So here you can see here, and again u into plus u into 1 by l. If you separate this, it will be u into 1 by l. ये तीन element है. So what you will do here? There will be summing block here. Input vector is u is there, but we want, along with u, we want one element 1 by l, and which is added, plus sign is required, so plus. Another is x1, its element is r by l. Here is x1 is coming like this through element r by l, but it is a minus sign, so in summation block I will use minus sign. Another one is x2. Where is x2? Here is x2. x2 signal is coming, it passes through element 1 by l again. Logically it is minus 1 by l, but we will not write minus sign here, so minus sign here will subtract. Means whatever the signal coming from the input through this element, from that these two elements along with state x1 and x2 will be subtracted and we'll get x1 dot. Let's go for x2 wala term. How you will get x2 dot? x2 dot is nothing but 1 by c into x1. Means this x1 of t, if it is passing through the element 1 by c, then you will get x2 of t dot. So we got this. And what about y? Y of t is nothing but x2 of t, and y of t is x2 of t. So जो हमें यहाँ पे integration करके we are directly getting x2 of t is nothing but y of t. So directly we wrote this, whatever is this line is nothing but y. So this is how we can draw state space model. If we take, say, some complex circuits, you may feel this state space model is somewhat complicated. Initially, I felt that it is very difficult to draw if we don't have some reference और किसी ने बताया नहीं तो. But there is, I found one technique. It will be very easy to draw this state space model. And if there are theory paper, if you don't draw state space model, your marks will be reduced. You should know how to draw. ये matrix मैंने जैसे के वैसे I have used from the previous PPT. Okay, you may see the matrix and the equation together here. That is x1 dot. x1 dot में क्या क्या आता है? Here is minus r by l, minus 1 by l and 1 by l. So minus r by l, minus 1 by l and u के साथ 1 by l. x2 dot में क्या आता है? x2 dot x1 का component है, that is 1 by c, but x2 component is not present, that's why 0. Again u input element is not present, that's why here it is 0. What about y? Y is nothing but x2. So y matrix का जो output matrix vector है that is 0 and 1 because 0 denotes that x1 term is not present in the output, but x1 denotes that your x2 term is present into the output as shown in the equation. So this is all the game of the equations, matrix and state space model. तीनों का proper रहना चाहिए. Let's go for the numerical 2. Numerical 2 is obtain the state space model of the given electrical network in the standard given format, whatever. So you can see now there are two loops. So input is there. There are two inductors L1 and L2, one capacitor C, and output of course one resistance. So again you have to think once the network is in front of you, you just look at the storing element, energy storing element. There are three energy storing elements, L1, L2 and L3. Sorry, capacitor C. Are you with me? Are you with me?
Yes, sir.
Okay. So minimum 3 state variables are required as there are 3 energy storing elements. Let's assign input ko. U is nothing but input matrix. Then x1 is nothing but current. Vary kya ho raha hai? Current, of course, input is changed, then these two current will be affected. So x1 is nothing but current I1, x2 state is nothing but current I2, and x3 is nothing but output. Sorry, not output. X3 is nothing but the voltage. So x3 is nothing but voltage across capacitor, which is nothing but integral of I1 minus I2 into dt. There must be one term here. It is of course the typing mistake here. 1 by C. 1 by C. Okay. So this is the capacitor voltage. Is nothing but the third state. Again, what is output? Output is nothing but the output voltage V0. And where, how do you get output? Output is nothing but voltage drop across this resistance, and that can be written by I2 into R. So it is I2 into R. But we know what is I2. I2 is nothing but X2. So we may write X2 into R. Please remember whatever are the standard forms, that is U, Y, X1, X2, Xn. Then we want final equation in terms of this, and along with of course elements L1, L2, R1, R2, C1, C2, whatever. So you can see here Y is represented in terms of state X2 into R. So Y ka equation khatam ho gaya. Now we'll go for the another equations. So we'll apply KVL in this loop. So apply KVL in first loop. It will be VI will be distributed across inductor and capacitor. So VL1 minus VC will be equal to 0. Put all the value, that is VI. Then inductor current you may write of course L1 di1 by dt, and capacitor voltage will be 1 by C integral of I1 minus I2 dt. But we know 1 by C into I1 minus I2 dt is nothing but VC, capacitor voltage, is nothing but state 3. So we kept it state 3. So we may write like this: VI minus L1. Here derivative of I di1 by dt is nothing but dx1 by dt, and dx1 by dt is nothing but x1 dot derivative of x1 plus what is this? This state is nothing but x3. We already have seen x3. Vi के जगह पे u put कर दो because Vi is nothing but u, and take it in terms of x dot. So we took x dot this side, we'll get u by L1 minus x3 by L1. In more appropriate form, you may write x dot 1 is equal to 1 by L1 u minus 1 by L1 x3. This is equation number 1. Next, we'll apply KVL in loop 2. Somewhat tricky, okay? Somewhat tricky, because we have to we are writing x3 in terms of I1 minus I2. Again, same mistake is there. Here is 1 by C. Typing mistake. So here I1 minus I2, and you will be getting I2 minus I1 into second loop equation. Just rewrite this: minus VC minus VL2 minus VR is equal to 0. Looking at the current direction, referring to this current direction, I wrote this. Then what is VC? VC is nothing but here 1 by C I2 minus I1. उल्टा है, देखो यहाँ पे, please make a note. Minus L2. L2 इसमें से कौन सा करंट पास हो रहा है? I2. So it will be dI2 by dt and minus I2 into R because यहाँ पे second current है I2. Okay. So here it is. If we write this 1 by C integral of I2 minus I1 dt, taking minus sign outside, you will get, it will be minus of x3. Therefore, ये minus of x3 and this minus sign will get cancelled. There will be x3 here minus L2. What is x dot 2? X dot 2 is nothing but dI2 by dt. This one dI2 by dt is nothing but dx2 by dt, and dx2 by dt is nothing but x dot 2. So L2 x dot 2 and x2 is nothing, I2 is nothing but x2. So it is x2 into R. Take it in term of x2 dot. So x2 dot on left hand side equal to minus R by L2 into x2 plus 1 by L2 into x3. Please remember, whenever you get this equation, maybe x dot, x1 dot, x2 dot, x3 dot, whatever, keep it in the descending order, like x1 pehle, x2 baad mein, x3, x4 likewise. Here x1 term is not there, so do not worry about that, but x2 and x3 term is there. So again, तीसरा निकालना बाकी है अभी, x3 dot. So how to do that? We know that x3 is nothing but 1 by C integral of I1 minus I2 dt. And what is x3 dot? Is nothing but derivative of this. So we'll differentiate this with respect to t. So differentiating that, we'll get x3 dot is equal to 1 by C x1. I1 is nothing but what? I1 is nothing but x1 minus 1 by C x2. I2 is nothing but x2. अगर किसी को समझ में नहीं आ रहा है, we may write this like 1 by C after derivation. It will be 1 by C in bracket I1 minus I2. And we know I1 is nothing but x1, I2 is nothing but x2. And combining this, you will get this x3. And we know that y is equal to I2R is nothing but y is equal to x2R. We already seen this. So we have total 4 equation. I have used this 4 equation on this PPT as well. X1 dot, this one, x2 dot, equation number 2, x3 dot, equation number 3, and y, equation number 4. And put all these equation into matrix form. So I have x1, x2, x3 dot. Then you can see in the first equation, I have only x3 term, which is x3 ka coefficient 1 by L1. So I wrote x3 coefficient, which is 1 by L1. Remaining x2 and x1 is 0. So this is 0. And u, there is coefficient for u. U is 1 by L1. So u ke liye we use 1 by L1. Again, x2 wale isme we have x2 and x3 term. So x2 is R by L2 minus x3 is 1 by L2 plus, and x1 is 0. Again, in this equation, I have only x1 and x2 term, and x1 is 1 by C and x2 ka coefficient is minus 1 by C. x3 is not present in this equation, so it is 0. Similarly, in these two equations, term u is not present, therefore coefficient is 0, no matter about it. And lastly, we have output, and output vector 3 इसका रहेगा, as we have 3 states x1, x2 and x3. Output vector will be of 3 element, and as we have 3 states, again input vector will also be of 3 element. Now here output vector may we do not have x1 term, so it is 0. We do not have x3 term, that is also 0, but x2 ke sath we have element, that is r, which is kept here. So once you get these two, now we have what, network. Then we found number of states from the energy storing elements. Then we found the equation in terms of x1 dot, x2 dot, x3 dot. Then that is nothing but what, स्टैंडर्ड फॉर्म में ये वाला मैट्रिक्स हमें मिल गया है, एक्स डॉट वाला मैट्रिक्स मिल गया है. Then we wrote this into the standard state space matrix form. Now the state space model. Now looking at the equation number 1, 2, 3 and 4, or maybe looking at this matrix, one may think that it is very difficult to draw the model for this. I also thought initially when I touched this topic, but it is very easy. First of all, your job is to draw one block for everything, that is x dot. It may be x1 dot or x2 dot or x3 dot, whatever. Then here in the block, you may write 1 by s or integration sign. The meaning is same. And of course, this is what, this is derivative. And if you integrate that, it will be what? It will be x1. Please focus on this, and later on, just check each and every element and each and every state how it comes. Means x3 कैसा आया है, x1 कैसा आया है, x2 कैसा आया है. We have to think of that. I'll elaborate the model. What I have initially, 4 equations, 1, 2, 3, 4 y wala. And what I will do, I will draw this one first, x1 dot and x1 बीच में integrator वाला, right? Another one is x2 dot, x2 integration का बीच में, x3 dot integrated, then we get x3. 3 ब्लॉक निकाल लिए हैं. Just focus on this. 1, 2 and 3. You please remember, your x1 dot, x2 dot and x3 dot is a combination of something. Thereby उससे पहले आपको put one, what we call, summing block. Okay, then come to the equation. इतना सब होने के बाद equation पे आना है. Then come to the equation. So what is x1 dot? x1 dot is u into 1 by L1. u किधर है? यहाँ पे. So u into 1 by L1 का element यहाँ पे लगा देना है. There is plus sign here. Thereby just connect it to the summing block and add plus sign. What is second term? It is 1 by L1 but has minus sign. Where from it is coming? It is coming from x3. Where is x3? x3 is here. Let's draw one line from x3, pass it through the element 1 by L1, drop it to the summing node near to x1 dot, and as it is has minus sign, put minus sign here. This term is over. Don't think of this again. This term is over. Let's go for another x2 dot. x2 dot, a combination of x2 and x3 state along with some element, this one. So summing block लगाया यहाँ पे. Let's see कहाँ से हुआ है ये. x2 से आया है through one element, that is r by L2. So x2 कहाँ पे है? Just after this block. This is complete is x2. x2 we drop one line from this, passes through element r by L2 and bring it to the summing block. And as it is a minus sign, put minus sign here. Another element रह गया है term. It has plus sign. Element is 1 by L2 coming from x3. Where is x3? Here is x3. Draw one line like this. Pass it through 1 by L2. End it to the summing block. Check the sign plus. Okay. Go for third. x3. ये कैसे निकाला है? इट इज कॉम्बिनेशन ऑफ समथिंग, दैट्स वाई समिंग ब्लॉक. इट इज कॉम्बिनेशन ऑफ x1 के साथ 1/c एलिमेंट विथ प्लस साइन. वेयर इज x1? हियर इज x1. x1 से एक लाइन ड्रॉ करना है, पास इट थ्रू 1/c एलिमेंट and drop it to summing block. Addition sign is plus. Another is x2, coming from x2 through 1/c element having minus sign. x2, where is x2? Here is x2, passing through 1/c element and has minus sign. Done. x3 dot is also done. Don't think of this x1 x2 x3 dot now. Last is y. In initial example y was x3, so we directly wrote it, but here y is not x3. I'll erase the ink. Okay, हमने पूरा ब्लॉक निकाल लिया है, only y का सोचना बाकी है. Here y is not x3, y is x2 into r. Take, where is x2? This is x2. Draw one line from x2, pass it through element r, and output is nothing but y. Very easy. And it is not necessary you have to say assemble this in this fashion. Okay, if you are taking these three block 1 2 and 3, ये 3 blocks जो है आपने ऐसे एक के नीचे एक भी लिया suppose, then it's okay. But whatever the logic connections as per the equation, it must be correct. Not necessary कि इसी fashion में आपको उसे assemble करना है. Is it? So this is all about numerical number 2. Numerical number 3. In initial numerical, am I audible? Are you with me?
Yes, sir.
Okay. So in earlier numerical, we had circuit diagram, but here direct equations are given. In certain question it may ask, obtain the space model of single input single output system represented by this. Very easy. x1 दिया है, x2 दिया है, y दिया है. x1 x2 दिया है, दो इक्वेशन है, means there are only two states, x1 and x2 respectively, and y is the output. Let's draw the diagram. State space model ही निकालना है. So what I said earlier, you have what? x1 dot, उसका ही निकालना है पहले. You just see x1 dot. If we integrate that, we'll get x1, or x1 dot is a formation of something, addition subtraction of something, so one summing block in front of that. Let's see x2 dot. x2 dot कैसे है? Here is x2 dot. x2 dot integrate करने के बाद x2 and again summing block in front of that. Okay, so we had only these three. Focus on these three only. Okay, now come to the equations. Now come to the equations. What I have, how x1 is formed? It is formed by two terms added together. x1, look at x1. Where is x1? Here is x1, along with coefficient or element a1. So x1 से एक line लिया है, passes through element a1 and again ended to the summing block with plus sign, of course. What is another? Another is u of t passing through b1 element. This is u of t से एक line लिया है, passing through b1 element and added to the block with plus sign. हो गया ये equation. Let's see for x2. x2 कहाँ है x2? This is x2 dot. x2 dot कैसे बना है? Let's see. पहला term x1, x1 के साथ a2. Where is x1? x1 we are drawing one line. a2 is element. Drop to the summing block. Sign is plus. Then x2. x2 कहाँ है? यहाँ पे. x2 से एक line. What is element? Element is a3. Passing through a3. Drop to summing block with plus sign. And last is u आ रहा है यहाँ पे, but through element b2. So u, draw one line, pass it through b2 and drop to the summing block with plus sign. So we finish with second equation. Third equation is y. Y is what? Y is what? It is addition of these two. Summation sign मिला है, तो you will be using one summing block here. What is y? Y is a combination of x1 and x2, but along with some elements c1 and c2. So x1 का है x1 passing through c1 added to summing block plus, then x2 passes through c2 added to summing block plus is nothing but 1. So this is how from these three state space equation we form this state space model. Again, not necessary to present this model in this fashion only. You may put any, say, component anywhere, but connection must be like this. Means आपने ये जो ब्लॉक है यहाँ पे रखा है और ये दूसरा ब्लॉक इसके सामने रखा है, and then you do all the connection. Y यहाँ पे रखा है, and if you do the connection between these three as per the logic or the equation, then you are correct. Representation view is not similar, but connection view will be similar for all the, say, different models made by, say, different people. Numerical number 4. Numerical number 4, what we have now, the state space model of differential equation. We have, instead of circuit, we have differential equation of the order 3, d cube by dt cube y plus 2 d square by dt square y plus 3 d by dt y plus 4y equal to 5u. We have to convert it into the standard form. So this is nothing but a third derivative. So I will write y 3 dot 2 into, this is second derivative. So I'll write 2y dot. This is first derivative. So I will write 3y dot, y double dot, then it is 3y dot, then 4y equal to 5u. So this is the equation. Now from where we have to get the states x1, x2, x3. Generally in the circuit, 3 elements are there, then 3 energy storing elements are there, then 3 states. Here check the degree of this differential equation, third degree, raised to power 3. So there will be 3 states here, and we have to obtain that. ये बाद में देखना है, ये half part है, we are going like this downward. So method 1 ही सीखेंगे हम. Just put y is equal to x1. Okay, then I will derive this y. I will derive this y, and that I will say x dot 1. Of course, इसे derivate किया, it will be x dot is nothing but y dot, and y dot is nothing but I am writing x2. ऐसे ऐसे आ रहे हम, we are writing x2. Again I will derive this x2. So x2 dot is nothing but y double dot is nothing but another state, that is, say, x3, and x3 dot इसे derivate करने के बाद we'll get third state. Of course उसे भी derivate करना पड़े, will be equal to y3 dot is nothing but d cube by dt cube of y. Once we get this, try to put this equations into the first and get in terms of x dot 3. ये third term के इस पे हम लाएंगे इसको. So putting all the values here, I get x dot 3 is equal to 5u. Input पहले, then decreasing form में minus 4x1 minus 3x2 minus 2x3. So put this matrix x dot वाला, x1 x2 x3 तीनों के dot इतने ही हमारे पास term है. This is the input state vector, that is x1 x2 x3 state matrix. This is the input vector. This is also state vector or matrix. So here let's check at x1 का term is -4 coefficient, of course. Here x1 के साथ -4, so here -4. x3 के सामने लिख रहे हैं हम यहाँ पे. -3 is for x2, -3 is for x2, -2 is for x3, -2 is for x3, 5 for u, 5 for u. Then this matrix is always constant. Here 0 1 0 0 0 1. If it is 2 by 2, then there will be 0 and 1. First row of the matrix will be 0 1. Then you will not find This term, it will be 0 because it is only referred to x3 term. And then what about y? Output. Output matrix y is equal to what? Y is equal to only x1. हमने यहाँ पे मेथड में लिया ही है. Y is only x1. So where is x1? Here is x1. Therefore only x1 वाला vector will 1. Remaining vector element will be 0. So this is how we can write state equations with the help if the differential equation is given. Now state space model, it is very easy. Just have three things here. x3 dot equations मी इथे घेतले नाहीत का? Please remember the equation. x3 dot, if we integrate x3 dot, we'll get x3. I'll go back every time. x3 को integrate किया है हमने, we'll get x3. And x3 is nothing but x2 dot. Thereby here x3 is nothing but x2 dot. We have not used the summing block here because x3 is nothing but x2 dot. If we integrate x2 dot, we'll get x2. x2 is nothing but x1 dot. And if we integrate x1 dot, we'll get x1. Few minutes more, we'll get x1. So you can see from this complete line, you'll get everything: x3 dot, x2 dot, x1 dot, x3, x2, and x1. Once we get, later on, check for the equations. Check for this equation. This one. It is a 5u. कैसे फॉर्म होता है x3? Just see. It is a x3 is nothing but it needs plus 5u. U से एक line निकला है through element 5 or constant 5 and plus sign. So it will be 5u minus 4x1. Where is x1? Here is x1. x1 से निकाला है constant 4 minus sign लगाया है minus 4x1 minus 3x2. x2 से लाइन निकाला है constant 3 minus sign 3x2 minus 2x3 minus 2x3. So this will provide, this point will give you the complete equation, that is x3 is equal to 5u minus 4x1 minus 3x2 minus 2x3. So this is the equation, numerical number 5. So here is all about the state space model. There are some more methodologies as it is there in the syllabus: parallel programming, canonical form, first-if form, then observability, controllability. That we'll see into the next lecture. We'll end this lecture with this slide. If you have any question related to state space model or the today's lecture, I'm here with you for 1 minute. Let me download the attendance because I have not downloaded attendance yet. Till the time, if you have any question, you may ask. How to download attendance? Yeah, no, yeah, download attendance. Okay. One more announcement. This unit requires about 9 lectures, but due to the less time, due to the university examination, I'll finish this with, of course, few number of examples. Number of example will be reduced. You will get all the concept of state space, but numericals will be, say, less. Examples will be less. So I will be finishing this, probably finishing this topic within 4 lectures. Today 1 is completed. Tomorrow I have arranged 1 extra at 12 noon to 1 p.m. and on Sunday I have arranged 1 2-hour extra class, that is 10 a.m. to 12 noon. So I think within this duration, I'll finish unit number 5. And of course, later on, if you have any say queries related to unit number 5, I'm with you. But I may not conduct a lecture later on for because remaining lectures and time is reserved for unit number 6 and will be conducted by Dekekar sir. So this is all about today's discussion. Thank you very much.